Okay, so today's video lesson will be on special angles narrated by Ruben. So, what are special angles? So, the special angles are 30, 45, and 60 degrees, and the trigonomic ratios of these angles can be determined using triangle 1 and triangle 2. Now, let's look at these triangles in more detail. So, as you can see from the first triangle, 45, 45, 90, and the second triangle, 30, 60, 90, all trigonomic ratios of these three values can be found. For example, when looking for the tangent of 45 degrees, tangent is opposite over adjacent, which is 1 over 1, and you get 1. It is important to note that the smallest angle is always opposite of the smallest side, and the largest angle is always opposite, or the largest side. So based on this, we can use it to apply to other problems. So, let's look at this. Determine the exact value of tangent 600 degrees. Since we have an angle which is more than 360 degrees, it means the terminal arm completes a full cycle around the quadrants, then continues further. So the first thing we're going to do is that we're going to want to remove the full turn. So it has 600 degrees minus 360 degrees. When subtracted, that gives us a total of tangent 240 degrees. So, since it's 240 degrees, we know it's going to be located in quadrant 3. We then have our normal angle. And what we're going to want to do now is find our acute angle. And the acute angle is always between the x-axis and the terminal arm. And to find the acute angle, it's going to be 240 degrees minus 180 degrees. And that's going to give us 60 degrees. So now, based on this, we can find an angle based on the trigonomic ratio of 60 degrees. We know that this side is going to be root 3. This is going to be 1. This is going to be 2. Since it is a tangent ratio, it's going to be opposite over adjacent. We then now know that tan of 600 degrees is equal to root 3 over 1. Now, based on the CAS rule, we can now figure out if it's positive or negative. We know that tangent will be positive in quadrant 3 and positive in quadrant 1. That means that this is positive and correct. Now, looking at the last example. A pine tree that is 10 meters tall is damaged in a windstorm such that it leans sideways to make an angle of 60 degrees with the ground. Find the exact expression for the length of the shadow of the tree when the sun is directly overhead. So the first thing you want to do is that you want to draw a picture. So I have a picture right here. However, we can draw a triangle to better look at or visualize what the question is asking. And as you can see, the shadow falls in the bottom part of this triangle right here, which means we're trying to find this side of the triangle, and we can make this x. Now, opposite to 60 degrees is here, the hypotenuse is here, and the adjacent side is here. We can set up a trigonomic ratio for cosine since we have adjacent and the hypotenuse. So cos 60 degrees is equal to the adjacent over the hypotenuse. Now, instead of inputting this in our calculator, we can use the trigonomic ratio for cos 60 degrees. And we know the trigonomic ratio for cos 60 is actually 1 over 2. So we can set that to each other. We can then cross multiply. We're going to get 10 equals 2x. Divided by 2 to solve for x. We're then going to get 5 equals x. Now this is the exact value of this shadow right here. Therefore, the length of the shadow is 5 meters.